Section 8.2 is going to look at multiplying radicals. In 8.1, we looked at simplifying radicals, which, if you remember, there's two ways to simplify radicals. We can use prime factorization or we can use perfect square. If you remember the pieces of a radical, the number underneath the radical is called the radicand. The number in front of the radical is our coefficient, and the little number that would normally sit right here, in this case it's a 2, is called the index. Remember that if there's no number written there, we assume the index is 2. Just like if there's not an exponent written on a variable, we assume the exponent is 1. It's just like that. It's always a 2 unless it's otherwise noted. So if we were going to simplify this radical, if I have 3 radical 8, I can identify the perfect square of 4 inside the radical and simplify like that. So, excuse me, 2 instead of 6. This is really 6 radical 2. Or I can say the prime factorization of 8 is 2 times 2 times 2. These are all my final branches. Anyone that gets a buddy gets to leave. So these 2's get to leave the radical, and the other 2 goes back under, and I'm left with 6 radical 2. You'll notice, after I fix my mistake here, you get the same answer either way. So remember, the choice is yours, whatever way you find easier. When we multiply radicals, we're going to multiply the coefficients, and then we're going to multiply the radicand. So coefficient times coefficient, and then radicand times radicand. Pretty similar to ways that you would multiply any other variable where you multiply their coefficients and then deal with their exponents. Same kind of idea. So an easier way to remember this, multiply outside by the outside, and then you're going to multiply the inside by the inside. If you use the actual terms, that's when you're talking coefficient times coefficient, radicand times radicand, and then this is really key. After you multiply, you must simplify your radicals. So multiply and then simplify. So here is an example of 7 radical 6 times 3 radical 10. I'm going to multiply their coefficients. So I multiply 7 times 3, and I get 21. And then I multiply their radicand. So I multiply 6 times 10 and get 60. So my radicands, my coefficients, and now I need to simplify. So I simplify, I'm going to use prime factorization. So 6 times 10, this breaks into a 5 and a 2. This breaks into a 3 and a 2. I circle my final factors. Anything that has a buddy gets to leave. So these 2's pair up and leave. I keep my original 21, by far the most common mistake. People forget that was there. I keep that 21, the 3 goes back under, and the 5 goes back under. They don't have buddies to leave the radical with. 2 times 21 gives me 42, radical 15, and that is my final answer. So I multiplied the radicand times the radicand and the coefficient times the coefficient, and then I simplified. Let's look at another example. If I have 4 radical 2 times 5 radical 3, I multiply coefficient times coefficient, so 4 times 5 gives me 20. And then I multiply radicand times radicand. 2 times 3 gives me 6. I must simplify. If I try to break down 6, I notice right away 3 and 2, neither of those have buddies. Nothing can be simplified, so this in fact is my final answer. That's possible. So in this case, we were able to simplify. In this case, we were not. If I look at the next example, 1/2 times radical 2 times radical 8. If you would like to simplify your radicals before you multiply, you'll get the same answer as if you multiply and then simplify. However, if you notice up here, this could not be simplified, and neither could this. 5 and 2, neither of those have buddies, and then 3 and 2, neither of those have buddies either. It was the multiplication that made it able to be simplified. So you do need to check whether or not it can be simplified after you multiply. If I do Radicand times radicand here, 2 times 8 is going to give me 16 under my radicand, and then my coefficient, no coefficient written, is really a 1. It's really a 1 here, so 1/2 times 1. This simplifies into square root of 16 is 4. 16, what do we call 16? 16 is a perfect square. 4 times the exact same thing, 4, gives us 16. 16 is a perfect square. This whole thing simplifies into 2. And then one final example here. Radicand times radicand. 18 times 2 gives me 36 underneath the radical. And then coefficient times coefficient. 4 times 3 is going to leave me with 12 outside the radical. Again, I think to myself, 36 is a perfect square. This is 12 times 6. 36, the square root of 36 simplifies into 6. 12 times 6 leaves me with 72, and my final answer is 72. So let me recap the steps here before we go on to a few more examples. When we multiply radicals, I multiply coefficient times coefficient. I multiply radicand times the radicand. And then the last step, that's really important for expressing my radical in simplest form, I simplify. Not too complicated, very similar to other things you've seen before. If you need help simplifying, go back to your 8.1 video.